tardes.
Good afternoon.
Event which will be held in English, but allow me to speak Spanish since one of the priorities of the Fundación Ramón Areces is to foster the use of Spanish language in science whenever that is possible. And today it is possible.
Dear Secretary General for Research, who hasn't arrived yet, but who will be here. Officials, contributors to Nobel Prize Outreach, and friends and followers of the Ramón Areces Foundation. Very special greeting to the associations of Spanish scientists abroad, some of which are following this online. Dear friends, since I'm the first to speak and no one's going to introduce me, I will introduce myself. My name is Raimundo Pérez Hernández, and I am fortunate to be the Director General of the Ramón Areces Foundation. On behalf of its Board of Trustees and Scientific and Social Sciences Councils, I'd like to warmly welcome you to this event, which we host jointly with Nobel Prize Outreach. I'd like to start by thanking everyone who has chosen to be here in the Foundation's conference hall. Thank you very much for attending and in such numbers. Secondly, I'd like to thank the whole team of Nobel Prize Outreach for their dedication, led by Adam Smith and Anna Sjostrom. I particularly want to remember Laura Sprethman, former Director General of Nobel Prize Outreach, who established this partnership, and we worked together for many years. It's always been a pleasure to work with Nobel Prize Outreach because of your professionalism and your charm. We have become good friends since in 2019 we co-organized the first Nobel Prize dialogue in Europe and outside Sweden on the future of aging. Thanks to that initial event, some of us have managed to worry a little less about our own rather concerning aging process. I think it was a very significant milestone which established mutual trust and sympathy, which I hope will continue in this partnership with Nobel Prize Outreach in the coming years. And the Nobel Prize conversations have become a tradition for the Ramón Areces Foundation. It's the seal, a program of activities presenting to the Spanish society the latest developments in scientific and technical research in the world, as well as latest in the most advanced thinking and academic circles. And we do this by attempting to combine the rigor and accuracy of scientific research with the ideas and trends of humanistic thought, which attempt to give consistent meaning to all of this process. In my view, the uniqueness of these Nobel Prize conversations is thanks to the originality and the uniqueness of the topics that are selected. They're not the usual topics, but ventures by qualified thinkers and scientists like the Nobel Prize winners today, who speak about intimate, personal, and daily issues leading human intelligence towards apparently incomprehensible or unreachable spaces. Other years we spoke about Inspired by Nature, which was about the relationship between creation and nature, or Imagination at Work, which was an exercise about the boundaries of any human imagination. And I think we can say that without these Nobel Prize conversations, Madrid Spring would not be the same. In 2024, we discussed the impossible take longer. And last year, we spoke about our future with AI, extremely current topic, which has only just begun and which we don't really know yet where it will lead us. this year, we're going to talk about where science takes us, looking back, looking forward, which we selected together with Adam Smith back in the day. And I'd like to explain a meta story of this title. We're celebrating this year in 2026 the 50th anniversary of the Ramon Areces Foundation. And we didn't want any big celebrations, but we did want to take advantage of this anniversary to reflect upon the past, present, and future of the progress of science and scientific research. And by the way, I do recommend that you read the special issue of the Ramon Areces Foundation's publication with contributions from several people present here today. The Ramon Areces Foundation has scientific research as part of its DNA. It has promoted the progress of science and scientific research during these years by funding research projects, establishing a broad and generous system of grants, and disseminating scientific output to benefit science society. And that's why we thought this was a great opportunity to think together about the huge progress of science in the last 50 years. And so we suggested this topic, Nobel Prize outreach, which fully shared our view and our aims. And I particularly want to thank our friend, Adam Smith, who I think turns our wishes into reality particularly effectively. Adam combines the analytical rigor of a scientist specialized in chemistry with that British sense of humor, but he's also a great moderator for the discussion, summarizing, improvising, and drawing conclusions better than anyone. Even though he seems very serious, he's actually particularly fun and charming and one of our favorites. And as Professor Krebs said, success is about thinking what nobody has thought about before. And that's something our Nobel Prize winners are well aware of. I'd like to thank them for being with us today, Benjamin List and Stefan Haupt, who will be introduced by Adam Smith, and so I won't be repeating their resume now. I'd also like to thank Professor José Manuel Sánchez Pavón, a well-known physicist and science historian, and the Spanish scientist Laura Nuño de la Rosa, who spent most of her career studying philosophy of science in history and the philosophy of biology. And I think their contributions are particularly relevant since science and philosophy interact and are mutually complementary. And this seminar and all the activities that we co-host with Nobel Prize Outreach is an attempt to appreciate scientists from a more human and personal perspective. And this partnership program takes shape through a series of podcasts, each of which includes a talk with one of the previous year's Nobel Prize winners on particular aspects of their personality. And you discover a lot of things, like, for example, that we're not as different as we might think, and that success generally arises out of a combination of values such as imagination, inspiration, observation, hard work, perseverance, and endurance, which some are able to maximize a lot more than others. And today, in my view, to conclude, it is more important than ever to support research. I think it is the main challenge for our modern societies due to the constant changes and challenges we are experiencing. We live at a time when people question certainties and paradigms of our past, and as Mario Benedetti, the Uruguay writer, said, when we thought we had all the answers, all of a sudden they changed all the questions. And that's why we believe that it's extremely important to present holistic, mainstreaming approaches to attempt to find answers to the new questions and new challenges that face us, and that's what these meetings are all about. And I'd like to finish finish by wishing you an enjoyable discussion. We will be reviewing the extraordinary progress of science in the last 50 years. Lenin said that there are decades in which nothing happens and weeks where decades happen. And in these 5 decades, a lot of things have happened, and that's what we're going to analyze today. In any case, we know, as David Hume said, that every new solution gives rise to a new problem. But that's probably going to be the topic of the next edition of Nobel Prize Conversations. Thank you very much. I'm going to give the floor now to Anna Systrom.
Thank you so much, Raimondo, and a really happy anniversary for the 50th year celebration. And I wish I could do this in Spanish, but you have to excuse me that I will do this in English. So, dear Nobel Prize laureates, Stefan Hell and Benjamin List, other distinguished speakers, José Manuel Sánchez-Ron and Laura Nuño de la Rosa, and of course to Raimondo. Ladies and gentlemen, friends and colleagues, we're so pleased to see the room full today. And I'm very, very happy to, after Raimondo's welcome, to also welcome you to this Nobel Prize conversation. And my name is Anna Sjöström-Douagy, and I'm the head of Nobel Prize Outreach. This is our 5th event in collaboration with Fundación Ramón Arreces, and as always, we are very, very happy to be back here in Madrid. Today, we will talk about where science takes us and about the evolution and progress of science. Every year, when new laureates are announced in October, we are reminded that science matters, that science changed the world, and that it undoubtedly benefits humanity in so many ways. And today, as Raimondo said, we will look both back and into the future. We will ask ourselves whether real progress is ever predictable, how dependent new discoveries are on emerging technologies, whether artificial intelligence will change everything, and what role imagination can play in scientific breakthroughs. Last year when we met, we had 2 physics laureates joining us, and today we are happy to have 2 chemistry laureates with us. And Stefan Hell received the Nobel Prize in 2014 for developing super resolved fluorescence microscopy, and Benjamin List received the prize in 2021 for his work on asymmetric organocatalysis. And they will be joining on stage by an historian of science, José Manuel Sánchez-Ron, and also a philosopher of science, Laura Nuño de la Rosa, which will be very interesting to hear the discussions. I would, of course, want to say a special thanks to Fundación Ramón Arreces and to Raimondo and his team for this wonderful collaboration that we have developed over the years. I would also like to thank the Nobel International Partners, ABB, EQT, and Scania for enabling this event. And of course, I would like to thank my great colleagues from Nobel Prize Outreach who is making this meeting possible. And then I would like to conclude also by mentioning the podcast, as was mentioned before, which is led by Adam Smith, our Chief Scientific Officer. The podcast is called Nobel Prize Conversation, and Adam will, of course, moderate this evening event as well. But the podcast has now more than 100 episodes, and in one of them is Benjamin List actually present, so don't miss that out. And once again, a very, very warm welcome, and I wish us all, actually, a wonderful conversation tonight. Thank you so much.
Good evening, everybody. So I'm Adam Smith, and allow me to add my thanks to the Foundation and to Raimondo and all of your team for so warmly welcoming us back. It is such a pleasure collaborating with you, and this feels like home from home now, so thank you. And after that ridiculously big build-up, there's a lot to live up to, so we'll do our best. And I'm relying on my panelists to help me cover this extraordinarily broad topic of where science takes us. This evening will be divided into 3 parts. First, I'm going to invite our 2 Nobel Prize laureates, Stefan Hell and Benjamin List, to join me on stage for a conversation. Then our other 2 participants will join us, and the conversation will be between the 4 of them, and then we'll open up for questions and comments from the audience. So, as you've heard, we have 2 Nobel laureates in chemistry, Stefan Hell and Benjamin List. They're also both based in Germany, and they're both directors of Max Planck Institutes. Benjamin List discovered organocatalysis, which is an entirely new way of catalyzing chemical reactions that leads to all sorts of groundbreaking possibilities. Stefan Hell developed super-resolution microscopy, which broke a rule called the Abbe diffraction limit, which had existed for over a century and allowed us to see more deeply into all sorts of different matter. And they're going to talk about those discoveries a little bit to get us going. So may I invite Stefan Hell and Ben List to join me on stage. Stefan, do you want to sit there? And Ben there.
Thank you.
Thank you. Yep, that's good. Okay. Thank you very much, both of you. So we're looking back over half a century of science, and so I should start by saying that if we wanted to have 2 people who had a research experience of half a century of science, we should have chosen older laureates, because both of you are young laureates, and you haven't spent half a century doing research. But you have spent perhaps half a century observing science, those initial observations in a very childlike manner. But you've had a view of science for half a century, and so I think you're wonderful people to be talking to about this.
Thank you.
You both chose your fields very well, clearly. You both made disruptive discoveries which have profoundly changed your fields. And so I'd like to start, by way of introduction, by asking you how you chose to work in those places. So let's start with you, Stefan. Why microscopy? You were a physicist.
Yeah, why microscopy? It's a very good question. In my case, it's actually a very special question because it's completely by coincidence. I studied physics in Heidelberg, no specialization in microscopy or optics in general. I wanted to do something profound, like becoming a theoretical physicist and thinking about all the matters of the universe and so on. But at some point, I felt that if I did that, I would possibly become unemployed because at that time it was very hard to get a job, theoretical physics. So I signed up with a professor who had founded a startup company specializing on microscopy. And I was asked to do a very boring thing, a very boring topic to work on, which is looking into microcomputer chips. And I found that so boring that I asked myself, what else would be worthwhile pursuing? And I figured out would be breaking the resolution barrier, which had existed for 100 years. That would be something that would be worthwhile pursuing. And that's how I got into that, pure coincidence. Had I not worked on the boring subject, I wouldn't be here.
It's an extraordinary jump to go from something boring to something impossible.
Yeah, but this was not, I mean, I couldn't have told you at that time that it would potentially end up in something very profound. I just did it because I felt it's cool to do. Yeah, it would be something worthwhile doing, and that's why I studied physics, to do something profound. And so eventually I was lucky and that I worked on something that really turned out to be useful and, of course, unexpected.
And may I just ask you to speak very briefly about what the effect of breaking the Abbe diffraction limit?
Yeah, you alluded to that in the introductory part. So people saw that in a light microscope it's not possible to see details that are smaller than about a fifth of a thousandth of a millimeter, so 200 nanometers. And that was perceived as a law. And I figured out that there is a viable physics, so to speak, in this world that allow me to break that barrier, to bypass that perceived limit, and to come up with a microscope that initially was 10 times better than people thought would be possible. Now we know it can be 100 times better, even molecular resolution.
And the effect of being able to...
But the effect of it, why is it important? You see, I'm not talking about the importance because I was just interested in breaking the barrier. But as a, say, collateral effect, it is useful in the life sciences because you can look into living cells, you can look into cells and see molecular details that you couldn't see before. And that's why the Nobel Committee decided that this is something useful, because it's very important to look into cells, because that's the only way we understand how cells work, and then it's the only way to really figure out in detail what is going wrong if the disease comes about. So it has implications for biomedical scientists.
Thank you very much, Stefan. Ben, in your case, you came from an intellectual family. Your aunt is a Nobel laureate, Christiane Nusslein-Volhard.
That's true.
So there was a lot of thought going on. You chose organic chemistry. Why?
Well, I have to go further backwards because I wasn't really aware that she was a scientist. She was just, a crazy auntie, and I didn't really think about what she was doing. And while she was a scientist and my great-great-grandfather was even a chemist, a relatively famous chemist, there were also plenty of artists in my family. My mom was an architect, her father was an architect, and now she's retired and became an artist. And my dad also is an artist or used to be an artist, and his dad forced him to be an art seller. I always liked this creativity aspect of the world. And chemistry is so beautiful in that regard because we have this analytical side of things, trying to understand the universe, having a better microscope or just understanding the world, but it also has this creative side of things, and that's chemical synthesis. I know it doesn't sound so appealing. Many people think, ooh, this is synthetic, but you have to be aware that all the drugs, all the vitamins, all the vaccines, they are all made using chemical synthesis, and in particular with chemical catalysis. So there is also a technical relevance to this field of catalysis. And yeah, that was sort of what drew me into organic chemistry and making molecules.
One of last year's Nobel laureates in chemistry, Omar Yagi, talks a lot about how he was drawn into chemistry by the beauty of molecules. Mm-hmm. Given the artistic side of your family, was that also something that
totally resonates with me? And I would even go further, because we're all kind of used to the fact that nature somehow is beautiful, right? You see a tree, you immediately understand the beauty of it, or you see a flower or an animal or the human body or the ocean or the stars. It's all beautiful. But human creations are not always beautiful, I would say. Sometimes they are, right? Good painting can be beautiful. And in chemistry, this is something, I mean, I'm the only one speaking about it. I don't know if you agree, but I feel the molecules that nature has evolved and designed are typically more beautiful than the synthetic molecules. Typically. Not always, but typically.
I think you need to be a chemist to make that refined judgment.
Probably. I agree.
And then you invented organocatalysis.
Yeah.
A left field idea that proved to be incredibly important. Could you talk a little bit about why it's so important?
Yeah. So you should be aware of the fact that catalysis is, on the one hand, an incredibly relevant technology. I like to say the most important technology for humanity on this planet, right? We wouldn't think that, but it contributes to 1/3 of the global domestic products, like plastic, fuel, vitamins, antibiotics, all that stuff. Everything is ultimately made with catalysts. And so catalysis is an established field in chemistry since over 100 years, and there have been a few Nobel Prizes, I think overall maybe 10 or so. But all of those awards went to people working with metals as the catalytic principle. And so that led to also what was perceived a law. You need for catalysis a heavy metal. And I don't have a problem with metals, but metals can be expensive and they can be toxic and they're rare. You have to, for example, the physicist knows this. Some metals require two neutron stars basically to collide to be formed in the universe. So they're relatively exotic. Iridium, for example. They come to us on comets and so on. So in contrast, organic molecules, for some reason, chemists have felt should not be good catalysts. Even though they are sustainable, as long as the sun shines, there's plants, and as long as there are plants, there are organic molecules on Earth. And so, yeah, it was in the beginning like a curiosity. Can I also use an organic molecule? The first papers were like, oh wow, this is also possible. Like, how exotic, how interesting. And now, 25 years later, it is the best technology to make these chiral mirror image-like molecules. And there's no company not using it anymore right now. So who would have thought that? It's really like a surprise.
Anna and Raimondo both mentioned in their introductions the power of imagination. And it seems in both of your cases that was very big. You imagined the possibilities of organic catalysis, and look where it took us.
Yeah.
You imagined you could break the limit. Could you?
Yeah. Exactly. It was imagination. I worked on this boring subject. It was very technical, and I really figured that breaking this barrier, getting a higher resolution microscope, would be extremely cool. And so I tried to imagine how would that be potentially possible. And eventually I figured out that there could be a way of doing it based on a very simple reasoning. This diffraction barrier, as I said, was found at the end of the 19th century, so it was 100 years earlier. And since then, so many new phenomena had come up in science, were discovered, physics, chemistry, of course. And what I imagined was pure imagination that there must be at least one phenomenon fully established that would allow me to bypass that barrier and come up with a microscope that is sharper. People have not just looked at it. And so I actually browsed through books, standard textbooks of atomic physics, nuclear physics, even molecular physics, to find the phenomenon. Optics, quantum optics, as a matter of fact, that's how I started out. And eventually I came across the phenomenon and said, okay, now this is it. And this could lead to it. But I figured that there could also be something else. And that was a pure process of imagination. So I have no proof. And then I went to the lab to make some assessments, numerical simulations. And then the next step was to make experimental proof. I think there is a parallel between some science, I think all science, but some science and art. We started out from this, actually. Very often in science, you start out from this creative and imaginative process, but the difference is that the artist doesn't have to prove that he's right in one way. The scientist has to prove that. And I can tell you, nature is merciless. Nature has its own laws, and there is no way you can deal with nature. So it is what it is, and if it works, it works. And this worked to my advantage because I had many critics who said, oh, you're not going to demonstrate, never ever going to work. But I felt that I would, in the end, win simply because I had nature on my side.
So it's imagination based on deep learning. And you might also call it optimism.
Yes, but it is optimism. Absolutely. I was relatively young, so when I got this idea, believe it or not, I was about 26, 27 or so, 25. And of course I was very enthusiastic. I wanted to do something with my life. I wanted to have an impact. I want to enjoy doing science in a way. Yes, optimism is a major part of it. I think without optimism you cannot be really creative.
Thank you both. So you've obviously had to focus quite hard on your own work, but at the same time you have the possibility to observe the broader field of science. And it's an impossibly difficult question, but looking back over what you've seen develop, just as a starting point, do you feel that the pace of scientific change is kind of even throughout your life? Do you feel that there's been major change in the pace of progress across your scientific lifetime?
I mean, there is some constant development going on. It's very clear, especially if a field is coming up, then there is some incremental improvement, and then the field evolves into what it is. But my take on scientific evolution is that quite often it takes unexpected turns. And very often solutions come out of a direction that you do not anticipate. So many people talk about the climate problems and they think we have to do this, we have to do this, we have to do that. But my bet is that most likely somebody, a woman, a man or so, will come up with a solution that no one has really anticipated. And all of a sudden, things have changed. And so this happens more often in science than people think. That's my take on it.
So when you look at the title, Where Science Takes Us, would you say that you have no idea where science will take you, but it will take you somewhere?
Well, to be precise, I have some idea where the incremental science will take us. Yes, that is predictable. So, and you have to do incremental. I don't want to play it down. We all have to do incremental science, and at times we do that. But be prepared for the things that come unexpectedly, because they will show up at some point, and they will be game changers. And they happen more often than we think. So we try to extrapolate things in a linear way, but mankind has not evolved like that. There have always been big jumps or whatever, big changes.
Yeah, I think I would even go as far as saying that for a scientific revolution to take place, it cannot be predictable. It's kind of incompatible even, right? So there is an element that I developed into sort of the list law. Scientific revolutionary ideas have to originally feel crazy by definition. Otherwise, it wouldn't be a revolution, right? Of course, unfortunately, while it is really a necessary condition for a scientific revolution to have a crazy idea, which at the time appears crazy, it is not a sufficient condition. So it can also be just a bad idea, right? So there is, of course, the mercilessness of nature, right, the truth, and then there is the mercilessness of our colleagues, right? If you go out there with a bad idea, it is risky, and it is challenging, and it doesn't feel good, I think. I mean, for me at least, the early days, when you pursue something where you know or where you're convinced nobody else in the world is doing this, it's not comfortable. It's not like sitting with you guys and chatting a little bit about life and the universe and science. And so, for us, though, this is where we must be. This is our homeland, I would say, right? We have to be where it's uncomfortable, where everybody sits by the campfire and discusses which AI they're using to design their experiments, perhaps. Yeah. We go into the dark forest, make the discovery alone in the cold. I mean, it's literally like this. I know it sounds kind of heroic, but I would really say it's a requirement.
Absolutely. I think a young scientist is now in the position, of course, of trying to figure out if a young woman or man is capable of doing something unexpected. Then I think you need to have a sort of appreciation for audacity. So does the person dare something? And Ben is absolutely right. So if you dare something that no one dares, the community will tear you apart at times, and it won't be nice. But again, the judge is nature, and nature is really merciless, believe me. So they will tear apart all those critics in the end. And in my case, this was the case. I mean, those who really oppose the development and had really fierce opponents, they kind of publicly opposed my appointment as a Max Planck director. It's even on file. You can look up. I can say it. Look up news in Nature, basically stating that I'm wrong. Yeah, that was kind of designed to prevent me becoming a director.
Well,
these other things, this happens. But in the end, of course, nature is merciless. Does the experiment work? Yes or no? And if it works, critics are being shut up. Yeah.
Well, you showed them because you're now the director of 2 Max Planck Institutes. So.
Yeah, exactly. Yes.
But in a way, as Max Planck Institute directors, your job then is to create an environment where people can live on that uncomfortable edge. And that must be challenging, especially in a world where people are perhaps more expecting applications of research. They're worrying more where their money goes. I don't know. Is the environment for this sort of science changing?
I mean, we are in a very, very comfortable and, of course, also very privileged position that we are members of this famous club called the Max Planck Society, and by definition we can do the science that we want to do. I think it's a fabulous organization, and the only, say, potential risk that we face is that we get complacent. So that we have to be driven, we have to be self-motivated to do something with the resources that we have. But I must say, for me, this has been most fruitful and most enjoyable to go about things that I really want to do, even after the prize. So this is just a fantastic setting.
Same for me. I mean, there is everywhere we go, there is the tendency for politicians to go away from fundamental science. They want to have some return of investment, right? So they give us the money, then they also want to have a new tool or something, right? But I think they are ill-advised, and the cultivated countries like Spain and Germany and the US, and traditionally at least, they have always invested in fundamental science, and they always got the return of invest. And fortunately, so far, the tendency in the Max Planck is not there that they ask us to produce a device or something. But it still comes. That's the beauty of it, right? It's like you don't push us for a technology, we bring it up.
And I mean, actually, the development of science testifies to the success of this approach. Because, as I said, I mean, usually a solution comes out of a direction that you don't anticipate. And if you program the science, you have to do this and this and this in order to sort out that and that problem. You just extrapolate, you just go for the incremental, and eventually the solution will come out of a totally different direction. And that's very important for politicians to understand, that you have to leave room for the unexpected.
You mentioned this, the need for audacious young people. Is there any change in the supply of audacious young people wanting to do things?
I mean, unfortunately, I would say I wish more young people would engage in science. That's my personal take, especially in the Western world. And being audacious is really important in science. Of course, it comes with a high risk. So if you're just about doing a career, then, of course, being audacious can be risky because, as Ben said, I mean, the colleagues will tear you apart. This will happen, for sure. But on the other hand, if you're not audacious, if you're not willing to take a risk, it's very unlikely that you come up with an unexpected solution that eventually wins you a prize.
I see ever brighter graduate students. It's fabulous. But it's true, they're less risk, open to risk, I guess, and often they discuss things like work-life balance. I was discussing it with the influencers before. Like work-life balance for me was never, or it still is not, a topic, because I pursue what I love to pursue, so this is my life, right? Talking about science, doing the experiment, doesn't feel like work. It's what I love to do. And so, yeah. But times have changed. Still, there's great talent, and I'm happy to report it's not going down, and interest is not sort of fading, at least in my experience.
Yeah. What do you think about people who ask? I mean, there have been a number of studies published, for instance, in Nature and Science, on changes in the rate of disruptive discoveries. Some of those papers have argued that the rate of disruptive discoveries is going down and that paradigm shifts are less frequent. Others argue they're going up. It's very hard. One has to look into the bibliometric methods and the citation analysis and ask what they're actually telling you. Do you pay any attention to that sort of thing?
My honest answer is no. Really no, because of course I encourage my own students to think in a very disruptive way and say, just go out and do something else. The only thing you learn from me is to be audacious. or to ask questions no one wants to ask, but just do something else.
Yeah.
I think that's enough. I think, in my view, that's perfectly enough, because it's a matter of personality to address, say, unusual questions, to ask differently, and to have a different view of some, say, accepted, say, laws, wisdoms, or whatever. And the only thing you can do as a senior scientist, you can encourage them to pursue that, pursue their crazy ideas or say, unusual approaches. But you cannot. I mean, you cannot change the best personality of a person. It's by that time too late in the early 20s.
I would only worry if the Nobel Foundation would decide to award the prize only every other year, right? Because somehow there's not enough interesting discoveries.
Well, we could turn that question back on you, because you both have the possibility of nominating for the Nobel Prize, of course, as Nobel laureates. Yeah. So do you yourselves find it just as easy as ever to think of new candidates?
We don't talk about it.
Unfortunately, so, we're not allowed.
Adam, you know that, and it's okay. But I see your point. Is it easy? I mean, yes and no. Yeah. Of course, you can pinpoint disruptive science. Yes. And of course, we think about what was the most important, say, disruptive discovery that was made not in the last year, but in the preceding years, that appears now to be the most disruptive. But we have to think about it. Sometimes it's very obvious. I'm not going to talk about it, but sometimes, of course, you have to ponder and to see. So, because it has also something to do with the fact that we're not experts in those fields.
Of course. And indeed, in your case, it was interesting to note that when you mentioned all the textbooks you read in order to work out whether you could break your diffraction limit, they were all physics. And yet you're a Nobel laureate in chemistry.
That's a good question. You should ask the Nobel Committee. I know not much chemistry, honestly. Yeah. And, I'm not. That's why I'm happy to have Ben here. Well, I mean, it was a physics problem. Let's be fair. And the solution that I came up with was a physics solution. That's fair. The way the Nobel Committee put it in retrospect, they said, okay, it has implications for the biochemistry of the living cell, and that's why it's chemistry. Okay, fine. But I think it's also fair to say that I used tools that the real chemists, came up with, namely fluorescent molecules. And those fluorescence molecules that were made by brilliant chemists helped me to overcome the diffraction barrier. So in that sense, it's just fine.
And it's also fair to say that these divisions are artificial anyway.
They are. Actually, in the year when I got the prize, 2014, the physics prize was given to the blue LED. And those people, as you know, they worked in part for a chemistry company. It could have been also a chemistry prize. We could have swapped the prizes. But, well.
I mean, chemistry ultimately is physics, right?
Thank you for saying that.
That's how chemists usually view it, and there's a truth to it. Our molecules are made out of elemental particles, and there's the quantum mechanics and the Schrödinger equation. So it is like physics. It's too complicated, though, for the physicists, right? Because it's multi-body.
Exactly.
And that's where they say, okay, no, I'm not touching it.
Yeah. Too exactly. I'd like to think it's simple terms. Yeah. And
exactly. But the chemists are very open to physicists winning their award. I'm at least, and also biologists, and because you could also make the same point. It's ultimately all chemistry, right? Because everything is made of molecules, and therefore it's chemistry.
Yeah, you two are very nice to each other. I know laureates can get quite hierarchical about this. Let's not go there. Right. Thank you very much. Let me please invite Laura Nuno de la Rosa and Jose Manuel Sanchez Ron to join us on stage, please. Do you want to sit next to Stefan? Just here? Thank you.
but we got problems.
Thank you. Yes, you got attacked by your own microphone. Thank you very much indeed. So, as you know, Laura is a research scientist at the Spanish National Center for Research, a philosopher of science who studies the history and philosophy, especially of evolutionary biology. And Jose Manuel is I think, known to you all, Spain's foremost science historian, and was 25 years Professor of History of Science at the Autonomous University of Madrid, and originally a theoretical physicist. So very nice to meet you. Laura, let me start with you. You do look back at the dynamics of the transmission of ideas. What is the value of doing that, do you think? Because I suppose that the question comes in the context of scientists who are, to put it simply, pushing forward and perhaps not looking back too much, but concentrating on where the forefront is, where that uncomfortable edge is, as we've been hearing. So what is the value to that effort of looking back?
Okay, so I would say, well, philosophy is like the mother of sciences, but many people think that that mother has been killed by its offspring. So, like science are the successors of philosophy. But what we actually do, philosophers of science, is look at problems and questions that actually traverse all sciences. And one of them, of course, is how ideas circulate, right? And where creativity emerges, what are the social conditions for that happening. And for that, I think that evolutionary biology is a very powerful analogical resource for concepts. So that helps us to explain, for instance, to look at when there is a conceptual gap in the history of science. So there are ideas which are proposed and they remain silent for 50 years and then they are rediscovered in a new conceptual technical context. So what happens? What are the conditions for that happening? Who cites whom? Why people cite some people and not others? So that kind of dynamic looks very similar to what we know about how populations evolve, actually. So what makes an organism successful, what makes an organism to reproduce more than other, what makes it fitter than other, can be actually applied to why some concepts are perceived as more powerful or successful than others. So that's what we do, applying these conceptual resources from evolutionary biology to understand the history and also the potentiality of current ideas, right? So also in evolutionary biology, evolvability or the ability of species to evolve is a topic of research, intense research, and that we look at that as well. If looking at the past of science can teach us things about the future of science.
And do you see changing patterns in the way that ideas are transmitted? I mean, that's a huge question and impossible to summarize, I'm sure, but if you could attempt.
Many patterns have been actually found. So, for instance, in this case, right, how limits or assumptions, deep assumptions, are broken in science, right? What are the conditions for these assumptions being broken? Or what are the conditions for creativity, scientific creativity emerging? So it's been found, for instance, that creativity happens more often in the interdisciplinary boundaries. So actually, so that I think these two cases are very good examples of that, about the boundaries between chemistry and physics, that where new ideas actually are more likely to be developed than in normal science, boundaried areas. So that's one very nice example of a common pattern.
And what about barriers to transmission? Because I suppose you find the places where it works, but also the places where it doesn't work. Do you highlight aspects of science that are holding up the progress of science, if you see what I mean?
Sorry?
The barriers to transmission. Does your work also identify things that are barriers to the transmission of ideas?
Yeah, I mean, precisely the conditions for, as Stefan was describing, right, why all the opposition he met in actually accepting a new idea, that has been very much studied by the history of science, or for instance Kuhn in the revolution of scientific theory. It's a very well-known example. So science actually is mainly normal science, and it's actually built on mechanisms for preserving common knowledge, right? And I think it has to be that way, right? Because there are many ways in which reproducibility of scientific results is ensured, and that actually distinguishes science from other disciplines like religion or other human disciplines, which do not have these mechanisms of ensuring that what has been published, actually all the retirements of papers in big journals like Nature and Science work precisely because of these methods of constantly revising what is common knowledge, right? So that has to work, but we need also mechanisms for that to be broken, right? So that's the tension that actually I think defines science, right? That common knowledge is reproduced by a huge communities of scientists, so science is not done by isolated geniuses. They are needed, but it's mainly a community labor, right? A community task. And we do need both kinds of mechanisms of reproducibility that actually try to keep new ideas out of it, and then we need mechanisms for breaking them. And that's the nature of science.
Thank you very much indeed. Stefan, did either of you want to comment on that duality?
No, I fully agree. I mean, my view is that humans tend to think in boxes. Like, okay, they categorize. So in my case, light microscopy is about getting resolution up to 200 nanometers, full stop. And that's a category, so to speak. And then if you want to go beyond that, you have to use electron microscopy, another category. But they forget what is the reason why it didn't go beyond the 200 nanometers. So this causal and effect thing, which is actually a fundamental trait of science, is forgotten in that very moment. So in the very moment you categorize, you forget causality. And so what you have to bring back is causality. And to ask, what is the cause of that? And is that cause standing the test of time if you look at it in a different way, if you shed new light on it, or if you just take it out of that box? I think this is very important. So it's very important not to categorize and to keep up this cause and effect part of science, which is the fundamental trait of science.
Thank you very much. Ben, did you want to come in? You don't have to.
No, I was just thinking that, is my microphone working?
Yes, I think so.
I was just thinking that...
It's not.
No. Can we fix that?
Okay. No, I just had this thought occur to me that, I mean, what was just said before is like you have to take a bird's perspective and look on a problem, and don't be caught up in the little jail that science sometimes seem to give us, or that scientists voluntarily confine themselves in, right? We believe in something, and so that's an important step. That's my take on it.
I mean, it very much resonates with me, actually, because I remember when I was my first year, second year physics student, then among us we discussed about certain phenomena in physics. And very often this saying came up like, oh, this phenomenon is about this, it's about that. But this is not how nature is. This is not about something. There is a cause and effect relationship. And it's very important for a student or any scientist to kind of inhale this cause and effect relationship and not to think this is about that. Relativity is about that. So what's going on actually? That's the point. What's the phenomenon?
It's all about testing the null hypothesis. It's all about testing whether the null hypothesis being that this will not have an effect on this.
Yeah, so the phenomenon is actually causality. It's not the phenomenon per se, or the outcome per se. It's the causality.
Thank you. Thank you. Yes?
Yeah. Well, I more or less agree with what you are saying, but my view of science is probably a bit more complex. I think, of course, I am talking about every aspect of science, not only fundamental science, but let's say so with applied science. It's not only to have great ideas, but there is a thing which is important, the relation with industry. Maybe you said that, of course, the science produce techniques, but the development of science also needs technology. It's very important. The interplay between science and technology is fundamental. For instance, in the case of high energy physics, without the extremely advanced in technology, there could have been impossible to produce the results that they have produced in the knowledge of the universe. What are the space telescopes, for example? They are really wonderful technologies. So we must to take into account that aspect of scientific research. It's not only the thing that one kid like you, Stefan, have a good idea, an interesting idea, search among the different possibilities in physics, but it's also, in one way or another, probably without one knowing it, the possibilities and the necessities of the time in society. And also, there is a point I want to remark, which your Nobel Prize illustrates very well, and you mentioned that you won the Nobel Prize in chemistry, but as you said, it could have been in physics, and I will add also in physiology and medicine. So this takes into the fore the question of a characteristic of science which is increasing since the last decades, interdisciplinarity. We have historically divided science, this is physics, this is mathematics, this is biology, this is chemistry, and so on, but nature is one. It doesn't distinguish between disciplines. And with the development of the different science, is almost impossible to my mind now, or very difficult to progress without taking into account or relating with other specialists.
Thank you. Can I pick up on the point you made? That, thinking of the biologist, Nobel laureate also, Sidney Brenner, he used to like to say that there were technologies and discoveries and ideas, and they were interrelated, and they were possibly interrelated in that order. So technologies led to discoveries, led to ideas, and back again. The ideas required new technologies. Do you think that analysis is correct? Do you think that sequence is right?
Resonates with me, at least. I was just thinking, like, Stefan has an idea out of the box, crazy. It works. It becomes a technology. Companies are formed, and people are using it, and then enable scientists to develop more crazy ideas. So what you were saying, and making new big discoveries. So it's clearly an interplay. I don't know if the order of events.
The order's difficult because if Sidney Brenner places ideas at the bottom of that hierarchy, it kind of removes that creative spark. But of course it doesn't. But it feels like it does. It feels like it does. But
yeah, I do not think there is a sequential relationship, but rather an interplay without any other. So I really like a metaphor by Rasmus Winter, a philosopher of science, who describes science as mapping the worlds, right, as a way of mapping. And in order to map and discovering new worlds, right, and incorporate them into our previous notion of nature, you need technologies, you need ships, you need telescopes in order to orient yourself on the seas. And that leads you to actually from mapping the world to mapping the universe, in the case of Galileo Galilei, for instance, and that came back to developing new technologies. He took them from the development of lenses, right, which was another field, from optics development, and also from Renaissance art, the study of perspective. So it's really impossible to make a sequence out of it, right? Really, technologies are embedded in theoretical assumptions. They lead to new theories. New theories lead to new technical development. But I think the metaphor of science as mapping the world is very powerful in that regard, because it includes both dimensions of science.
Thank you, Lara. And taking us to the universe, Jose Manuel, you would argue, I think, that if you look back at the last half century, the cosmology is a good candidate for the science that has moved furthest.
Yeah, well, the last 50 years have been extraordinary for the development of our knowledge of the universe. Let me make a personal comment. When I began my doctoral dissertation in relativity, my supervisor, who was a very distinguished specialist in relativity, I am talking about the first years of the 70s, 1970, in the decade. He didn't believe in black holes. He thought that they were a sort of ghost or solution in the field equation of general relativity. Well, now we know that black holes are everywhere, even probably in the center of every galaxy. So when I was beginning my career as a theoretical physicist, before I became a historian of science, more or less we have an idea of the composition of the universe. We only have an idea of the 5% of the composition of the universe. So that means it's wonderful for that to have problems to question to answer. But I will say that as far as science is concerned, the universe is the field of science which has revealed more surprising in the last 50 years. I don't know if you agree with that.
Anyone nobody has to agree or disagree. We can just have.
Yeah, but I have a question. I have a question for you. So why did he not believe in black holes? He must have had a reason. Yeah. Was it purely physical, or did he dislike the person who came up with it?
Well, no. Well, think about this. You must be a black hole. It's something very surprising. Energy must come into some region and disappear. So you must be really a believer to think in black holes, because they are very surprising objects, cosmological objects. So in the early 70s, I don't think it was surprising, in the equation, the fundamental equation of practically every theory, electromagnetism, gravitation, general relativity, there are cosmology, relativistic cosmology. There are many possibilities of universes. There are the possibilities of many universes. In principle, there is one. I remark in principle. And we say of the other, this cannot be. So my supervisor thought that those solutions of the field equation of general relativity, which were associated with black holes, were, as we will say in the case of relativistic cosmology, other universes which don't exist. So it was not something surprising. I was thinking it was to some sort of logic.
I was just thinking that I'm not surprised that surprises seem to be popping up more, Because if you think about it, whatever the nature of the reality of this universe is, it must be mind-blowing. It's impossible to not be mind-blowing, right? Why is there something and not nothing? How did this all come about, right? So it must be ultimately shocking and beyond any human mind, I would my guess. But I'm not a physicist.
I always try to my students when in history of science, and also when I was teaching theoretical physics, is to say nature is more creative than human mind. And the problem, I don't know if to say the problem or what is wonderful, as we as human mind, human beings, are able to discover theories as counterintuitive as quantum mechanics.
Mm-hmm. Yeah, absolutely. Yeah.
I want to open up for questions in a minute, and we have a lot of topics to cover in this conversation. We must, of course, talk about AI and what is to come. But just before we leave the conversation in the panel, we've been talking a little bit about interdisciplinarity, and I wanted to ask about the relationship between science and the rest of society, science and humanities. I mean, science doesn't exist in a vacuum. It's very much influenced by this. Laura, would you like to talk a little bit about that? It's closest perhaps to your topic.
Yeah, well, before that, I must say that as a philosopher of biology, that life, I consider life to be more wonderful than, it can be considered more wonderful than the entire universe. I mean that there is not unified, there is not unique nature, right? We tend to talk about nature in upper cases, right? But there are many natures, and one of them has originated in this planet, and the origin of life might be more mysterious than the origin of the universe itself, right? So I'm not sure if I will share some view on intelligence, right, and the universe. But related to how science and humanities relate, as you said, science doesn't happen in a vacuum, right? In order to understand science development, we really need to understand the political, religious, and societal and cultural context, right? I was mentioning Galileo before, so if we don't understand how Galileo was relating to Renaissance theory of perspective, it would be impossible to understand how he saw what he saw through his telescope, right? Or Darwin, for instance, the theory of natural selection cannot be understood without him reading treatises in economics and demography, right? So that was a product of his time, right? And without that context, we cannot understand. So the evolution of science is not the evolution of pure reason responding to internal conditions of theory development, right? So that's where I think humanities and science meet, and understanding the context where science is developed. And also understanding that science is not an individual enterprise, as you were saying before, but a community enterprise. And we need to understand sociology in order to understand how science works, right? It's not about, again, the evolution of reason, but actually the evolution of communities of human beings. And currently, in a globalized world, science has become a distributed, globalized enterprise where labs are distributed all over the world and they depend on each other. And if we don't understand how the world works, we won't be able to understand how actually science is practiced. No? We still tend to tell these very individual biographical stories about discoveries, right? But that's actually just one very small dimension of what science is. And for that, we really need social sciences and humanities into the picture.
It's an appealing dimension, though. We like our stories of.
We do, yeah.
They
are storytellers, yeah.
We're storytellers, exactly, and it brings people into science. Or into any field. We depend on that. So It's interesting. I don't know if it was very eloquently said. I don't know if anybody wants to comment on it or we move on to questions.
No, I agree. You cannot understand the history of science and the development of science without taking into account all these elements which Laura mentioned. Certainly. It took me, however, some time to realize that, because I was a theoretical physicist, and the theoretical physicists are the worst physicists in science.
Why did you switch from being a theoretical physicist to a historian of science?
It's easy, because I think I will be a better historian of science than physicist. And I enjoy writing too, and making connections. And one of the characteristics of science is that you have to concentrate in order to be competitive, to be the first or in the first group. You must to concentrate in one field. And I always I enjoy looking more broadly. So I was saying that it took me some time as a theoretical physicist to understand really what science is, and history of science helped me in that sense. And one of my books is El Poder de la Ciencia, The Power of Science. Has a lot of economic, sociology, religion, all those elements which, of course, you shouldn't reduce. Science has something particular, the work both of you do. But in the whole, the history of science is something which is deeply connected with the whole of society.
Thank you very much, yes. And to be a scientist, yes, you must focus and you must forget about life-work balance. Let's open for questions, please. So, I think we have microphones. Please put your hand up. Yes, one here, please. Yes. One here, yeah.
Thank you very much for your contributions. We love them. I was wondering, according to you guys, what is the biggest mystery in life that we are still trying to figure out?
Okay. Yeah. Quick answers.
Yes. Sure. Why do things, the universe, the laws of physics, why do exist? The origin of everything. I think from the Big Bang, if in the future we keep believing that there was such a thing, I think we will be able to explain everything. But why happens that thing called Big Bang?
Does anyone want to boil it? Thank you. But does anyone want to boil it down to a tractable research question?
I have another untractable.
Okay.
And that's consciousness.
Consciousness, yes, okay.
Well, consciousness eludes science completely, and people have tried. There's hundreds of theories of consciousness, and we always believed there was the Big Bang, and then matter arose and energy, and then out of that biology somehow came along, and medicine, and the brain was formed. And in this brain, consciousness somehow arose, emerged, but it's not understandable. And yet, if you think about it, the fascinating thing is all we perceive, all we have ever perceived, all anybody can ever perceive is made out of pure consciousness. And science somehow ignores that.
Yeah, but I think it's not understandable, but it will be understood.
You think so?
Yes.
Okay, good luck.
I am a materialist.
It's been a bit of a graveyard place to go for scientists.
That's true.
Yeah.
I mean, Max Planck, if I can add to this, said, I believe consciousness to be on a deeper fundamental level than matter. Something like that. I paraphrase, but something like that. Good challenge. But I wouldn't recommend it for the next generation. I think it's hard.
Thank you for the question. Did you have one? Yes, please.
Good afternoon. My question is a question open. I don't want to personalize it. Adana has mentioned just a mention about AI. Do you think the AI will be creative even more? Do you think the AI can reach a Nobel Prize?
So, yeah, there's a lot in that question. Thank you.
Yeah.
I'd love to know your take. Thank you very much for introducing the topic. Where is AI taking us? Can I extend your question to say, is it a technology unlike anything else we've ever seen that is going to change the way we do science, you do science, and change science in the future? And yes, will AI be awarded the Nobel Prize in the future?
I think I can very confidently say no. Because it's not in Alfred Nobel's will. and there's no word, I've seen it, and there's no word saying it could be given to something else than a human. And so I think the guys who decide on the prize, they will have to stick to that testament. It's that simple. And therefore the answer is no. But your question is, of course, has a more serious connotation. Is AI coming up with real discoveries in the future that really are to the greatest benefit of humankind? I suspect so. Yeah, I suspect so. So I'm quite optimistic in that regard because we spoke about consciousness. That's my take. Yeah. So, and I may be completely wrong. What's the deal? What's the deal? Why not? I mean, if a neural network is very elaborate and kind of mimics the human brain to some extent, or any brain. I mean, animal brain. I mean, maybe animals have consciousness in a sense. So they're not that different. The brain looks pretty identical to ours. Yeah. Why should not an AI come up with something that is unexpectedly important? I wouldn't say so. Yes, I think I would imagine that. But would it get a Nobel Prize? No, because it's not in the testament.
Lara, you want to come in on this, and Ben also?
Yeah, well, actually, I mean, there have been papers published by machines, right? So that might change. But what I would what I would say is that question assumes that actually there is a relationship of identity between human intelligence and artificial intelligence. And what I profoundly disagree with is about taking out from the picture the material and bodily dimension of cognition, right? So cognition is embodied cognition, and affection is deeply embedded into how we understand things, right? And how we create ideas. So I really like this case of, probably you have heard about it, of this, it was the best player of Go, this Asian chess game. And he was defeated by artificial intelligence several times, actually 4 times out of 5. When AlphaGo was actually showing up into the picture, so it was actually very young when he defeated it. And he quit Go. He stopped playing. And when he was asked what happened, he said that was not the same game, right? So the thing is that a game is not only a collection of algorithms, right? It's not only about selecting the best move, right, in order to win the game. It's actually about defeating the other, managing tiredness, right? About the beauty of the compositions of the pieces, right? Or in a chess game. So that all belongs to games as apparently algorithmic, right? Like Go or chess. And that's not in artificial intelligence. It's only about algorithms, right? the body, the affection is out of the picture, and that's part of human cognition. So I think that's the main thing that is being left out of our understanding of artificial intelligence. Yeah.
Thank you. Yes. Go is often called a conversation with the hands, isn't it?
Yeah. Very shortly.
Okay.
I think artificial intelligence won't be able to discover, to create general relativity. That's something, but it will be able to discover the structure of DNA. And DNA has produced a scientific revolution. So we must be careful because artificial intelligence will probably will affect more deeply some disciplines more than others.
Thank you. Thank you. And Ben?
I mean, you could, following up on what you said, you could say that there was already a Nobel Prize given to artificial intelligence. It was AlphaFold, at least one.
The physics prize was also given.
Yes, because they solved basically a fundamental problem of biology, chemistry, and physics. That's how proteins shape into their three-dimensional structure. However, the data that was used was to the biggest extent created by humans. So I'm not sure if you're right that without the data, artificial intelligence would have predicted the DNA structure. You need crystal structure or computed structures that people have somehow provided before. And this is also true in a way for the large language models. It's like a fancy Google. They can search but they can. I have a feeling they cannot create. But I'm also very open to the possibility that one day it somehow emerges and then it starts.
And just very specifically in organic synthesis, how helpful a tool is AI now?
I don't want to offend my colleagues in the field, and we are all fully into it. And I probably our institute will completely change in the coming 20 years, and we will all do AI and have everything predicted and so on. But currently, I always like to see a problem being solved. And so far, in my field, chemical synthesis and catalysis, I would argue no real problem has been solved. It's nice and fancy papers come up with good pictures and good ideas.
Thank you.
I hope I didn't upset anybody.
Thank you. Please, there's a gentleman at the back. Please.
Yes, question to all panelists, if possible. Do you think the universe is rational, or do you think rationality is the way to approach and try to understand the universe? And I would like, if possible, to have the vision of the scientist, of the philosopher, and of the historian about this question.
Thank you. We're getting very deep. Who's brave enough to start?
It's a very difficult question.
Shall we start with the philosopher?
Okay. Well, I don't think the universe is rational, but the assumption that it is rational was what led to the origins of astronomy, right? So both Kepler was a super believer, Galileo as well, Newton, of course. So they all assumed that the universe was rational, right? And originally, the belief that every planet moved into circles was actually founded in the assumption that the circle was the most rational possible geometric figure, right? And in the case of Kepler, it was a tragedy to recognize that it was not a circle, it was an ellipse, and that was more irrational than we thought, but still it was the same figure, right? So rationality got detached from particular geometric figures in order to be related to uniformity or to symmetry more generally. So these kind of assumptions, looking at simpler explanations, for instance, that endorse the assumption that the universe is elegant, is rational, is metric. These kind of assumptions have led science progress, but in the way science has found that there is a lot of chaos, right, in nature as well, and that's a fundamental component of nature. In the case of biology, for instance, randomness is actually the motor of evolution, right? So I do not think so, but I think it's been a motor assumption that has made science progress, in particular the study of the universe.
Thank you very much indeed. I think I'm going to encourage people to give really short answers because I want to get in a few more questions before we have to finish. So, Ben?
I would say that for the universe to be rational, it implies it's sort of comprehensible with our mind, and I would exclude that. I would say the universe is beautiful. It is what you said, there is beauty clearly, right? There's intelligence, a huge intelligence, but it will never be fully understood. It's impossible.
Stefan, do you want to?
Honestly, I have difficulties with the problem rational because I don't know what it means.
Yeah.
And I definitely do not know what it means in this context.
Honest answer. Yeah. Thank you. Do you want to answer?
I'm going to complicate the question. I am not sure that there is only one universe. No. This, of course, the multi-universe. I think Copernicus taught us that Earth is not in the center of the universe. Darwin, that we are not a privileged species. I think in the future, I believe in that. Someday it will be found that our universe is not unique. So, coming to your question, I think this universe, our universe, seems to be a rational one, or at least why? Because we are able to understand rationally the things with the technical instrument we have developed, see. But what about these future possible universes?
As if we didn't have enough to cover in one universe, looking at where science takes us. Thank you. Okay, we had a question here, a quick one, and there's one right at the back. And I don't know how long we can carry on doing questions, but I'm going to keep going for a little bit. Please.
Thank you. Welcome to the group session.
I mean, if you're honest to your true experience, to your actual experience, then what I said is true. There is only consciousness. So you could say matter is a concept, whereas we can, for 100% certainty, confirm the reality of consciousness. It's a fact, Yep. So I resonate with this idea. Experiential, right?
And all of this could just be in our heads.
Yes, and that also.
Yes. Thank you. Question right at the back. Thank you very much. Lady down here, question at the back. Yep. Okay, I see you as well. Yes, please. One. Please. Oh. No, you go first then, and then you. Yes, okay. You.
Very rarely in my case.
Yeah, but Ben said it very rarely. So what I'm doing, I'm designing experiments. So I have students who work with me, so those who work closely with me, there's a few, there's maybe 5 to 6, 7. I work very closely, so I'm conceiving the experiment and have a possible view of the outcome I'm checking out if the things come out I anticipate or if there's some surprise. So in that sense, I'm very, very close to the actual experiment, but do I drive the screwdriver and put the screws together? No, possibly because I'm not good at it anymore. And the young generation would do it much quicker than I would do, and don't want to disrupt them. But I'm still very, very close to the actual experiment.
I always do the experiment when camera teams come.
But it seems the answer to the question of where science takes us is out of the laboratory and into the office. So. Okay, at the very back, you have the microphone. Can you turn the microphone on? Thank you.
So I would like to ask something about the nature of discovery, because there's this idea that discoveries are not made by people, but have the time to occur, and then they occur. Like, for example, the radio or non-Euclidean geometry or evolution were discovered by different people at the same time. And of course, there's the previous science of the time, the economics, the incentives. But do you think if this is true, there's something more to it?
There is something what?
Sometimes something more to this idea that discoveries were not made by people, but somehow many great breakthroughs occur to different unrelated independent people at or very close to the same time.
I mean, can I comment? Yes, no, I'm sorry. Discoveries are made by people because science is made by people. I think it's. I really believe in that. But is it true that some discoveries are, so to speak, timely in a way because there is the conditions in the world that can kind of allow these discoveries to take place? That is certainly the case. Yeah, I mean, we all live our lives and we live in our say social and contemporary context, of course, and that favors certain discoveries. But discoveries are made by people. But this brings me to a very important point. That's actually my point. What is actually a discovery? So this is really, really interesting in my view. It's not enough to have an idea. It's very important to realize what that idea really means and to prove to the world what the consequence of that idea is. I give you a simple example. Who discovered actually America? Was it the Vikings? They went there, no doubt, there's no doubt about it, and the Vikings set the foot on America. But what difference did it make? Nothing. It didn't change Europe. It didn't change America, I mean the indigenous people there. Didn't change China. Nothing. There was no consequence. Maybe had some consequences on the local people there. But when Christopher Columb went to America, all of a sudden everything changed. Europe changed, Asia changed, America changed, everything changed. So that was the actual discovery. Discovery means not only that you set the foot on the ground first, but to make a transition that has a consequence for humankind. This is very important to realize. And this is made by people and not by I don't know what.
Thank you very much. I really want to get in a couple more questions, because I know I don't have very long. Please go ahead. Quick questions, very quick answers.
Good day, Dr. List. What is the most exciting moment in your career? Was it when you discovered the catalytic activity of the proline?
What was the most exciting moment in your career? Was it the realization, the actual discovery, the building of your first proline-based chiral catalysts, or?
There's so many. The life of a scientist is full of exciting and beautiful moments. Clearly, the discovery, my idea, what I have thought about, what I rationally designed, I put into the test tube and then I see it works. It's extremely satisfying. But then there are other moments. I mean, when the call came, it was overwhelming. I rarely tell the story, but It was like, hi, this is Göran Hansen from the Nobel Committee. I have good news for you. And my answer was like, oh, I can't believe this is happening to me already. I'm so excited. I don't know what to say. And they say, wait, I didn't even tell you what I'm going to say. And I was like, I just want the telephone number of Professor McMillan. And so, for this moment I was shocked. But yeah, anyway. But I have so many moments of joy, like celebrating a discovery. Some graduate student comes into my office and says, listen, Ben, I found this. What do you think? And then we try to figure out what he has discovered. There's so much joy. I would say that having chosen this career of discovery, of being a scientist, is my source of happiness.
Thanks.
Thank you. A nice question. We have a microphone here. Do we? Quickly. I know there are lots of hands. I know. I see.
First of all, thank you so much for this unique conversation. I'm a clinician and a researcher as well. And before we started this meeting, I was talking to Benjamin about how science and art combine. Like, we need creativity, and it's been on the table. My question is about a very interesting article. I cannot recall the name, but it discussed how researchers with broader interdisciplinary training may have higher probability of making serendipitous discoveries and often achieve greater citation impact, right, on articles, while at the same time they face more criticism from their peers. How do you view this tension in scientific publishing? I don't know if you're familiar with this. It became a very popular article.
Is it a tension still?
Yeah, I agree with that. I agree with that because, I worked as a physicist. I worked on a physics problem, but it had implications in biology, but I didn't know much biology, almost nothing. Chemistry was equally ignorant about. And so I had big difficulties finding a job, among others, because I didn't convince the physicists, but I didn't convince chemists or biologists, because they knew no biology, and they realized that. And of course, I published initially in very low impact factor journals, because my work didn't resonate with any of those three communities. So I'm a very good example that really testifies to the notion that you have given. On the other hand, that's also true. There's many, I would say, pseudoscientists who are who hide behind interdisciplinarity. And if you look at those science or scientists, there's depth neither in physics nor in chemistry and nor in biology, which will be okay. But if you combine the three, there is no depth at all. So there's zero depth. And that, of course, kind of leads to this notion interdisciplinarity can be kind of wacky.
Thank you. Thank you for the question. This has to be the last question, please. Quick question.
So quick question. Talking about the refused ideas that came into a Nobel Prize after, about how world change and how our mind change when we go further. Have you ever think, or are you concerned about how the scientific paradigm change despite the non-won Nobel Prizes? Have you ever think how are the consequences of the non-won Nobel Prizes, and how different could be the scientific paradigm? What is the reason of selecting one ideas or non-others? Coming from this all over rejected ideas could be great ideas that change our world.
But I suppose that question suggests that the award of the Nobel Prize somehow changes the world's reception of an idea. And I suppose maybe the question is about whether a non-won Nobel Prize is kind of a lost idea, but hasn't changed the world. But perhaps that's not. Perhaps we could change that question just to finish on, to say, does the receipt of a Nobel Prize, do you think, change the way that the ideas that you're working on, the discovery, are received by the world? Has it made a difference to the impact of organocatalysis or super-resolution microscopy, or were they already out there but when the prize came?
Yeah, I think it's fair to say yes. Yes, it has an impact because also science to some extent is a kind of sociological process, and it has impact in two ways. Some people who worked in the field and thought that they would make a major difference and perhaps share a Nobel Prize, they may have not been incentivized anymore afterwards because the prize is given. Yeah, so such phenomena exist. And of course, so the Nobel Prize has an impact on the sociology of science. Yes, it's totally out of question. And does it give more visibility? For sure it does. Yeah, absolutely, yes.
Quickly, I would agree completely. And those merciless colleagues who hated you for your crazy idea at the beginning become glowing supporter after the Nobel Prize.
I agree.
Some at least. Yep, there is some truth.
Some do. Not all do.
I know there are still hands raised, and I know there'll be great questions, but we have to stop because we've got a fantastic reception to go to, and hopefully the conversation will continue there. But just before we go, we haven't touched very much at all on what, looking back over the history of science and the way science has developed, allows us to say about future discoveries. And it's very hard to say anything, so I'll let you off the hook by allowing you just to say something very brief, but I would like to hear something very brief about what we could say about what is to come from each of you. I'm going to start at that end.
Multi-universes.
Multi-universes, okay. Very brief, good. Thank you. Lara.
Well, I'm not sure, but I think synthetic biology, so our current ability to modify life, might have, I don't know, unforeseeable consequences, because actually one of the traits of life is its autonomy. So we don't know how they will react, how living organisms will react to our interventions. So if we don't disappear as a species before that, I think that, we'll learn many things about that in the future.
Thank you, Lara. Stefan?
I genuinely believe that breakthroughs are unexpected. Full stop.
Yep. I was just going to say the same thing. I expect the biggest discoveries, the most exciting stuff that will come is that which is not predictable. But if I have to say one thing, then it is CO2 splitting. That's the chemical reaction we work on, that we want to save the world with. Splitting CO2 into the elements, making solar carbon, and releasing oxygen back into the atmosphere. That would be my dream, at least. But as I said, most important stuff, most exciting stuff is surprising.
Thank you all very much. Thank you to the entire audience for being here and making it possible